Let's continue with the car battery discussed in the previous screencast, the battery I used for years in my classrooms. It's a favorite demo and nicely gets across the basics of circuits. I want to now direct attention to electric power. Here we have the 12-volt battery with extended terminals. The terminals are brass rods, but in practice they could be ordinary copper wires that thread from a power source to lamps and other devices that you find in your home. As before, I connect identical bulbs with alligator clips between the extended terminals. All bulbs have a resistance of 6 ohms. The single bulb in the lower branch carries a current of 2 amps. Why 2 amps? From Ohm's law, 12 volts divided by 6 ohms equals 2 amps. Then we see the middle identical branch also draws 2 amps. How about the top branch with two 6-ohm bulbs in series? Well, the resistance of the top branch is 6 ohms plus 6 ohms equals 12 ohms. With this twice as great resistance, the top branch draws 1 amp of current. And with 2 amps in each of the lower branches plus 1 amp in the top branch, how much current flows from the battery? Did you say 5 amps? Yum, for sure enough, that's the current that flows through and is provided by the battery. But you know all that, right? And we see all the bulbs light up. What we want to know is, how does the relative brightness of these bulbs compare? We know that each of the top 2 bulbs is dimmer than either of the bottom ones because current in the top branch is less. But here's a question to consider. Will the total amount of light from the 2 dim bulbs be the same as that of one of the lower bulbs? We can think of it this way. Suppose we're in a dark room and we light the room with both bulbs of the top branch. How bright will the room be compared with how bright it would be if we just used one of the lower bulbs? Let's think about that. Investigating the brightness of light bulbs is where the concept of electric power comes in. Recall that power equals the amount of energy consumed per unit of time. It turns out that electric power in any branch of the circuit is simply the product of current in the branch times voltage across the branch. In equation form, power equals IV. Recall that power is expressed in units of watts. That's 1 amp times 1 volt equals 1 watt. The more power a bulb dissipates, the brighter it is. You know that a 100-watt incandescent bulb glows brighter than a 60-watt bulb, even though most of the power is dissipated as heat. Let's look at the power consumed in the lower branch, in the 6-ohm bulb. Power on that branch is 2 amps of current multiplied by the 12 volts across the branch. That's 24 watts. So 24 watts of power is dissipated in the filament of the bulb, the region of highest resistance. That's why the bulb glows. Likewise for the middle branch, which is electrically identical. So the middle bulb also dissipates 24 watts of power. Now how much power does each of the 6-ohm bulbs in the top branch dissipate? Well, we know the current in each is 1 amp. What's the voltage across each bulb? Recall voltage drop? Since the bulbs are equal in resistance, can you see the 12 volts across both bulbs in the branch divides evenly? So there's 6 volts across the first bulb, and it follows that the power dissipated by the first bulb is 1 amp times 6 volts equals 6 watts. And the power on the second bulb, also 6 watts. So the power on the top branch is 6 watts plus 6 watts equals 12 watts. This checks for taking the branch as a whole. 1 amp of current times the full 12 volts across the branch produces 12 watts. That's 12 watts for both bulbs combined. So in answering our original question, we see that the 2 bulbs together dissipate less power than either single bulb in the lower branches. That means the 2 bulbs in the top branch emit less light than either of the single bulbs below. In reality, brightness is not exactly proportional to power because the resistance of a bulb depends upon the temperature of its filament. but less power definitely means less brightness. What total power is consumed in the 4-bulb circuit altogether? We see it's 60 watts. Let's ask a related question. What's the power supplied by the battery? We see that's going to be 5 amps times 12 volts equals 60 watts. And that checks. Yum yum. It all hangs together. Now, if you understand this, you can answer this question. Let's suppose instead of powering the circuit with 12 volts, we power it with a 6-volt battery. Can you show the power put out by the battery would be equal to 1/4 of 60 watts? And can you defend your answer? Perhaps by letting an equation guide your thinking? I hope so. Until next time, good energy.